Hello everyone, I'm Zsara Bianca Campano, a BS Applied Physics student from CMPL Semicon Lab under Dr. Elmer Estacio and Dr. Bardolaza, and this is the overview of my thesis. Optical parameters describe how a material interacts with light. These values are frequency dependent and are necessary in designing devices that operate in specific frequencies. Two of the optical parameters studied in this thesis are the refractive index and absorption coefficient in the terahertz frequencies, which is the region in the electromagnetic spectrum that ranges from 0.1 to 10 terahertz. In this experiment, we employed the terahertz time-domain spectroscopy where a femtosecond laser is used to emit and detect terahertz pulses in order to determine the optical parameters of semi-insulating gallium arsenide and lightly doped N-type silicon. The time-domain spectra of the samples were taken relative to and were compared with the reference terahertz pulse. This time-domain information was imported to Python version 3.9.14, where the data was transformed into the frequency domain via Fourier transform. Amplitude and phase information were then extracted to solve for the material's optical parameters. The frequency-dependent refractive index is contingent upon the material's thickness and phase, while the frequency-dependent absorption coefficient is contingent upon the material's thickness, refractive index, and the signal amplitude. The experimental refractive index of SI gas was found to be in close agreement with literature values published by Grishkowski and Mavrona, while the experimental refractive index of light NSI is also in close agreement with the published values by John and Grishkowski. Moreover, the experimental absorption coefficient of SI gas is in close agreement with the published literature values by Grishkowski and Mavrona, while the experimental absorption coefficient of light NSI is also in close agreement with published literature values by John and Grishkowski. Oscillations may be observed from both plots, which may be caused by Fabry-Perot modes due to the unevenness of the sample surface and back reflections. The higher experimental refractive index of SI gas suggests that the employed terahertz frequencies travel slower in the sample than they do in light NSI. The higher absorption coefficient in light NSI suggests that the sample absorbs more of the employed terahertz frequencies per unit length than SI gas. Thank you for listening.